Hey there, today we'll be doing this question that is 1 to 9, some root to leaf numbers on Leetcode. And the given question statement is you are given the root of a binary containing digits from 0 to 9 only. Each root to leaf path in the tree represents a number. This part is very important. For example, root to leaf path 1 to 3 represents 1 to 3, and we need to return the total sum of all root to leaf numbers. This part is very important, that is root to leaf numbers. And what does it mean? So let's understand this with an example. So root to leaf means we start from root till the leaf node, and the leaf nodes are those nodes those are having no children, and that is what a leaf node is. So we have to generate all the root to leaf nodes number and sum every one of them. So what are the possible numbers here? One of the path we can take is 495, this one, and the other part can be our 491, this is one of them, and the other one could be that we take 40, this one. So whatever the summation comes out to be, that is our answer. Fine. So this is what we have to return. Now how do we do this question actually? So a prerequisite to this question would be you should know pre-order of the binary tree, pre-order traversal. So if you know pre-order traversal, you'll be good to go for this question. So pre-order basically means at first we go to the root, after that we go left, and then we go right. That is what pre-order means. So we'll be tracking the number in some manner, and we'll be taking on by doing a pre-order traversal. Let's see how. So at first we started the root, fine, and let's just say we have a sum variable which is storing our sum, and there is a variable called temp. Now what is this temp doing? We'll come to it. Okay, so let's just say we are at the starting point, so at 4. So somehow in my number I'll just create this number, okay, and store it here. And how are we creating? We obviously do know how to create these numbers. That is, whatever the number we have, we just simply multiply it by 10 and we add the number. Sorry, this should be the variable temp, that is temp. Okay, and this is a very simple thing that we do, and this is how it gets generated. Let's just say if our first number is 4, so temp's value initially is 0, so 0 into 10 plus 4, 4 will be generated. Okay, after that we have 9, so the next number would be 49. So my temp's value is 4 right now. 4 into 10 is 40, plus next time I will have 9 here, so it will generate us 49. So this is a pretty basic thing that we do to generate numbers, right? So yeah, coming on to the temps value. At first we have 0, so 4 is generated. Now pre-order traversal means we'll go to the left first. Fine. So here we come on to this part. Now here we'll go to the root first, and we know that is this is the root here, right? After that, what are we going to do? We are going to generate the number. So we generate the number, that is a new number comes out to be 49, right? So 49 is generated. Now we go left. After that, we see that 5 is there. Now we generate a new number, that is 495. 49 is cleared, and our new number is what? 49 and 5. This, that is 495. So now comes the most important part. If we see we are at some node whose left and right child does not exist, that means I cannot go any further. Then I'll say that okay, whatever number I have generated till now, add it to my sum. So initially my sum's value will be 0. I added it to my sum. So my sum's value is now 495. Okay, now comes the interesting part. So we know in pre-order, up till this thing is done, so it will go back. Now it will try to go to the right part, obviously. So now when we try to go back, what are we going to do? We are simply going to say whatever number I have in my temp, I will just delete the last one. And how are we going to delete the last number? We'll just simply say temp by 10. We'll just divide it by 10 so that the last digit is deleted. Now my number stands out to be only at 49. Okay, so the last digit is deleted. Fine. Now as the pre-order goes, we'll just simply go on to 1. We'll create a new number, that is 491. Now again we'll just check that condition, is it satisfying? Does this node not have left and right children? That means that is true. It only has null, it does not have any children. So what are we going to do? We are just going to add it into our sum. So 491 will also be added. Now this thing is also done. Now we go back. Now we try to go back. This is done. And remember, while we were going back, what are we going to do? Yes, we are just going to delete one by one every number. So 1 is deleted. Now when we go back to 4, what will happen? We'll again go back to 4. So now again one number will be deleted. Now we are only left with 4. Now we'll come on to this part, that is 0. Now we see that 0 is there. Okay, form 0, done. Now yes, again we just check if the left and the right node are not present, that is it is null. That means the childrens are not there, it is a leaf node. What are we going to do? Yes, we are just going to add it into our sum, and whatever the summation comes out to be, we are just going to return that as our answer. So this is the whole intuition and the whole walkthrough of this, of how we are going to do it. Now if you will see the code, you'll understand it perfectly fine. Once you see the code, it will be very easy for you to understand on how this is working totally, and it will be very clear to you. Okay, so now let's move on to the code part, and also the code will be linked in the description. You can check it out from there as well. So this is a pretty simple code, very small code. So at first, what have we done? We have taken a sum variable, okay, and we have taken a temp value. If you see in the function, this is right here. So we have taken a sum variable and a temp variable as discussed right there. Now, what are we doing? We are saying if it is a null, then return 0. What do I mean by this? So let's just say somewhere around this, if I try to go left, is there any node there? Obviously not. So we return something, right? We return a null. So that is why I've said if there is no node present there, you just return 0. You don't have to do anything. But if there is a node, I go inside and I do form the number. That is what we had done there, right? We were just forming the number by that formula. It is very simple. Whatever the number is, multiplied by 10 and just add whatever the digit is. It is very simple. This thing. So this is actually used many a times. Okay. So after that, we were just checking if it is our last leaf node. That means it is our leaf node and we do not have any left or right children. What are we doing? We just say add it to my sum, right? That is what we were doing when we had found that this is the leaf node and there does not exist any left or right children. That is what the meaning of leaf node is. What did we do? We just added whatever the number I formed into my sum. That is what we are doing here. Now this is a simple pre-order traversal. We go left first, then we go right. And remember, whenever we were backtracking, that means whenever we were going back, what did we do? We deleted the last digit. So this is what we are doing. We are just deleting the last digit, and at the end of the day, we are just returning the sum. So this is the whole code here. And I'll just reiterate the backtracking part. That means this part, let's just say 4, 9, and 5 was formed when we are here. This thing is done. Now we see that the whole number is formed. Left and the right children does not exist. So we go back. So what do? We just delete this. And now we come on to this one and we form this 491. Okay. So this is what the backtracking part is. And this is the whole code right here. And I hope you have understood the whole thing. And if you still have any doubt, you can ask me obviously in the comment. I'll be replying to it. And yeah, if you did like this explanation,